Convergent series. Suppose that the sum from r equals 1 to n of f of r is equal to g of n, and it's a series with the partial sum g of n. So we say partial sum. Partial sum means like just the sum starting at r equals 1 and then just ending at a particular point. And so we call this partial sum here g of n. And we can actually calculate the limit as n tends to infinity of g of n. So if the limit as n tends to infinity of g of n is equal to L, when L is a real number, then we say that the infinite series, the sum from r equals 1 to infinity of f of r, is convergent and equal to L. Otherwise, if that limit does not exist, we say the series is divergent. So just to be clear about this sum from r equals 1 to infinity, so sum from r equals 1 to infinity of f of r, this really does mean the limit as n tends to infinity of the sum from r equals 1 to n of f of r. In other words, it's just the limit as n tends to infinity of g of n. And it either exists or it doesn't. If g of n gets closer and closer to some number L, the more of these terms we add on, so the bigger we let n get. If the entire sum gets closer and closer to some number, then we say that this series is convergent, and so that limit exists. So you can think of it as summing to L. The more of these f of r terms we add on, as r gets bigger and bigger, the closer and closer it should get to L. So yeah, as I've said here, that as n gets to infinity, g of n gets closer and closer to L. Now, there is a precise mathematical definition of what this actually means. So this has a precise mathematical definition. I encourage you to do a bit of research about it and see if you can get your head around it. So that would be some good extension work. In fact, I remember now we already talked a little bit about this in the rational functions 1.9 video, where we talked about the epsilon delta definition of the limit. So yeah, go check out the epsilon delta definition of the limit if you have some time, although it's certainly not part of the further maths course. Anyway, getting back on topic, let's do an application of that. So exercise 3.9, show that the series, the sum from r equals 0 to infinity of 40 times 1 over 2 to the power of r is convergent, and find its value. Okay, so we know that this is equal to 40 times the sum from r equals 0 to infinity of 1 over 2 to the power of r, which is equal to 40 times, and then for r equals 0 it's just 1, and then for r equals 1 it's just a half, plus a half squared, plus a half cubed, plus ... and it goes on forever. And we know this as the geometric series from back in P1. So this is equal to 40, and we know that this sum is, the sum to infinity of this thing is just 1 divided by 1 minus r. So 1 minus a half. So that is just equal to 80. So just in case you forgot what that is, or you really shouldn't have, this is the geometric series. So that is a sum of the form from r equals 0 to, say, n of, let's use a different letter here. Let's use k. K equals 0, because normally we use r, actually. So the sum from k equals 0 to n of r to the power of k, and then if we take the limit as that tends to infinity, we get that it's just equal to 1 divided by 1 minus r, as long as the modulus of r is less than 1. Okay, now it is convergent because we know that this thing here converges, which means the more of these things we add on, the closer and closer it gets to this number here, which is 2. So if we keep going, 1 plus a half squared plus a half cubed plus ... the more of them we add on, the closer and closer it's going to get to 2. So that's why this whole thing converges. It's going to converge to 40 times 2, which is 80.